Hi learners! On this video lesson, you will learn about perpendicular lines and the angles formed at their point of intersection. All intersecting lines here are assumed to be on one plane. Visual representations will be shown to let you understand the concept easily. Real-life examples will be cited to make the concepts relatable and meaningful. Strategies in analyzing and answering sample problems related to the topic are demonstrated to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on perpendicular lines, rays and line segments, or if you have an assignment on these topics, or if you are preparing for a test in math, or a test in geometry in particular, or you're someone who is interested in learning math, then this video is for you. In an earlier video lesson entitled Intersecting Lines and Their Angles, we learned that intersecting lines are lines that produce angles of varied measures at their point of intersection. But when the lines intersecting at a point form 90-degree measure, as shown here, a special name is given to these intersecting lines. We call these lines perpendicular lines. These, together with the angles formed at the point of their intersection, will be the focus of this video lesson. So, perpendicular lines are two intersecting lines forming four 90-degree angles at their point of intersection. The angles with a measure of 90 degrees is called a right angle. This measure is usually represented with a box to indicate the angle measure of 90 degrees. Whatever their position is, as long as the box is there, the lines are perpendicular. We have seen earlier that when the measure of one angle is 90 degrees, all the other angles have the same measure of 90 degrees. So even if only one angle is marked with a box, the other angles are also right angles. In geometry, the convention is to just have a single box. Let us name some points on the lines and name the lines so that we can write some mathematical statements about the lines. The symbol to indicate that the two intersecting lines are perpendicular is like an inverted T. It looks like this. When lines are perpendicular, as in this case, we write this statement this way. This is read as line A is perpendicular to line B. Remember that we can also name the lines using 2 points on it. So we may write this statement, line RO is perpendicular to line TO, instead of the first. Because rays and line segments are part of a line, they may also be described as intersecting when the lines containing them are intersecting. Let us have this diagram, learners. We will name the lines as lines D, E, and F. And the angles as angles 1, 2, 3, 4, 5, and 6 in our diagram to make it easy for everyone to follow and understand the discussion. Here, the diagram tells us that line D is perpendicular to line E because angle 2 is a right angle. Can you follow, learners? Since line D is perpendicular to line E, there are 4 right angles that are formed at their point of intersection. Do you agree, learners? Now, where are the other right angles? Only one is marked here. Let us locate them. Let's go. Here's the other one. Remember that vertical angles are congruent, so if angle 2 is 90 degrees, then angle 5 is also 90 degrees. Did you get it, learners? Remember that the right angles are formed at the intersection of 2 perpendicular lines, so here is another one. Here, the box is on 2 angles. It means that the measure of the 2 angles add up to 90 degrees. That is, the measure of angle 1 plus the measure of angle 6 equals 90 degrees. Do you get it, learners? And here's the fourth one. which is on two angles as well. So the measure of angle 3 plus the measure of angle 4 is 90 degrees. Now, look at angles 2, 3, and 4, learners. What is the sum of the measure of these angles? Take note that all these angles are on one side of line D. Okay, the measure of angle 2 is 90 degrees. On the other hand, the measure of angles 3 and 4 add up to 90 degrees. What is now the measure of the three angles? Okay, so the measure of the three angles add up to 180 degrees. Did you get that, learners? That is the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Now, how about the sum of the measure of all the angles on the other side of line D? We see the same thing, right? The measure of the angles on the other side of line D also add up to 180 degrees. That is the measure of angle 5 plus the measure of angle 6 plus the measure of angle 1 equals 180 degrees. That is also true for all the angles above line F. The sum of their measures add up to 180 degrees. The same thing with the angles below line F. So, remember these, learners. For two or more lines intersecting at a point, the angle measures of all the angles located on one side of a line always add up to 180 degrees. Again, it will be good to remember that when lines are perpendicular, it is unusual to put the four boxes on the four right angles. The convention is to just have one box on one angle. Now, where do we see them in real life? Where do we see perpendicular lines in real life? The truth is, perpendicular lines are everywhere. We have them inside the house, like the intersection of the floor and the wall, the corners of the room. Even the frames that are on the wall have them. We also see them on roads and bridges. We see them on lampposts and ground, on trees and the ground, and on fences. So we see them everywhere. Learners, do you have other examples of perpendicular lines in real life? I'm sure you will find lots of them. Okay, let us do sample problem 1. Here is the problem. Given the diagram below, part 1, which statements are true? Option A, line N is perpendicular to line P. Option B, the measure of angle 7 plus the measure of angle 6 equals 90 degrees. Option C, the measure of angle 2 plus the measure of angle 1 equals the measure of angle 8 plus the measure of angle 7. Option D, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Part 2, what is the measure of angle 1? Option A, 40 degrees. Option B, 50 degrees. Option C, 80 degrees. Option D, 90 degrees. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Okay, what are asked in the problem, learners? The problem is asking for two things. First, we're asked to determine which of the statements in part 1 is or are true given the diagram. Second, we're asked what the measure of angle 1 is. So what are given? We're given a diagram of intersecting lines with some angle measures. We will answer part 1 first. Here, we are to determine which of the statements are true given the diagram. This is how we will answer the question. We will deal with the statement one after the other. Identify the concept or concepts that relate to the statement, then apply the concept in determining if the statement is true with the use of the diagram. We will begin with option A. Here, The statement says that line N is perpendicular to line P. Remember that if you are given a diagram, all you need to do to find out if the two lines are perpendicular is to look for the angles formed between these lines. If the measure of the angle is 90 degrees, then the lines are perpendicular. Let us look for these lines and check the measure of the angle formed. Let's go. There you are. Here is that box. So the lines are perpendicular. We move on now to option B. Option B states that the measure of angle 7 plus the measure of angle 6 is 90 degrees. Is this true? We learned earlier that line N is perpendicular to line P. This means that these two lines form four 90-degree angles or four right angles. Let us look at the diagram and locate angle 7 and angle 6. Let's go. Here are the angles. These angles are at the point of intersection of lines N and P. So the sum of these two is 90 degrees. Did you get it, learners? Okay, let us now move on to option C, which states that the measure of angle 2 plus the measure of angle 1 equals the measure of angle 8 plus the measure of angle 7. Is the statement true? We will look for these angles in our diagram. Let's go. From the figure, we can see that all the angles are located on the right of line M. Earlier we said that for two or more lines intersecting at a point, the angle measure of all the angles located on one side of a line always add up to 180 degrees. Now, if the measure of angle 2 and 1 is equal to the measure of angle 8 and 7, that means that the measure of angles 1 and 2 add up to 90 degrees. And the measure of angles 8 and 7 add up to 90 degrees as well. This would imply that lines O and line M are perpendicular. Are these lines perpendicular in our diagram? Okay, so they are not. We do not see a box or any sign telling us that these two lines are perpendicular. Did you get it, learners? Okay, so we move on to option D. The statement is the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180 degrees. Okay, we first have to locate where these angles are. Let's go. Here are the angles. What do you notice about them, learners? Okay, so angles 1, 2, 3, and 4 are all located on one side of the line of line O, which means that the measure of their angles add up to 180 degrees. Were you able to follow, learners? So, what are our answers here, learners? Is it option A, option B, option C, or option D? Okay, so the answers are options A, B, and D. That was easy. Let us now move on to part 2. Here, we're to find the measure of angle 1. We learned from part 1 that this statement is true. So, we can use this in answering the problem. From the figure, the measure of angle 2 and angle 3 is 90 degrees. And the measure of angle 4 is 50 degrees. We will plug this into our equation. We now have the measure of angle 1 plus 90 degrees plus 50 degrees equals 180 degrees. Adding 50 degrees and 90 degrees gives us 140 degrees. Subtracting 140 degrees from both sides of the equation gives us 40 degrees. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option A. The measure of angle 1 is 40 degrees. That was again easy. Now let us move on to sample problem 2. Here's the problem. Use the given diagram below to find the value of x. Here are the options. Option A, 21. Option B, 84. Option C, 90. Option D, 180. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. Okay, what is asking the problem, learners? Here, the problem is asking us to find the value of x. What are given? We're given a diagram having intersecting lines with angles formed at their point of intersection. We're also given an expression for the measure of the angle. Okay, so the diagram tells us that the intersecting lines are perpendicular because of the 90-degree angle measure at their point of intersection shown by the box. Do you see that too, learners? Since the lines are perpendicular, each of the four angles has a measure of 90 degrees. So the angle with the given expression is equal to 90 degrees. Can you follow, learners? That is, 4x plus 6 degrees equals 90 degrees. Take note that we're to find the value of x here. So we will rewrite first the equation and then solve for x. Subtracting 6 degrees from both sides of the equation gives us 84 degrees. Dividing both sides of the equation by 4 degrees gives us the value of x. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option A. There you are, learners. The value of x is 21. Now, how do you know if your answer is correct? All you need to do is to plug in the value of x that we got into the given expression. If it will give us 90 degrees, then the value of x is indeed 21. Okay, let's do it. Now, multiplying 21 and 4 degrees gives us 84 degrees. Adding 84 degrees and 6 degrees gives us 90 degrees. Indeed, the value of x is 21. There you are, learners. I hope you have acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, intersecting lines are two or more lines crossing or intersecting at a single point called the point of intersection. Second, two lines intersecting at a point produce vertical angles that are congruent. Third, perpendicular lines are two intersecting lines forming four 90-degree angles at their point of intersection. Fourth, for two or more lines intersecting at a point, the angle measure of all the angles located on one side of a line always add up to 180 degrees. Fifth, when solving a problem, you must read it and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what you are looking for. Sixth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below and don't forget to like, subscribe, and share this video to your peers so others will